Welcome back to Learning with Ms. H. Today we are in an earth science lesson and we're going to do a lesson over earthquakes. Grab out whatever you're going to take notes with, in or on. We're going to do notes over earthquakes, followed by an assignment, and then you will need your plate tectonic maps at the end of that to fill in the fault lines on it. So we're going to go into the module for today. The lesson for today. You just did the bell work. It is for points. If you did not do it, please make sure you do get it done. We are going to do notes over earthquakes here. All right. So, an earthquake. Earthquakes happen at fault lines. This is the shaking of the ground that we feel. What's actually happening is that rock underneath the surface is shifting and moving, and it's either rubbing against each other or slamming into each other, pulling away from each other. There's some kind of movement going on underneath the surface there. The field that studies earthquakes is seismology. The scientists that work in that field are called seismologists. Earthquakes work based on the elastic rebound theory. So when the force exceeds the friction, the rocks are going to move. They're going to break and snap back into their original shape, not necessarily their original position. So if you have rocks pushing against each other, eventually the friction between those two rocks is going to be overcome by the pressure of them pushing or pulling, and they're going to slip. So if they're pushing towards each other, they're going to slip and one of them's going to go up. If they're pulling away, they're going to slip and release and make that rift or trench. And if they're sliding side by side, they're going to slip and they're going to shift one direction, one the other. They're going to go back into the shape they started in before they started pushing on each other, but they are not necessarily in the same place. So, for example, the San Andreas Fault out in California, it is that side-by-side one. So it is going to slide side by side, and remember we had you rub your hands together, and you could feel kind of the bumpy as the tops of your palm slid past each other. When it moves all the way past, slides all the way past it, that's going to be that rebound. So if you think about pulling on a rubber band and stretching out the rubber band, when you let go of the rubber band, what happens? It snaps back. So you're putting that tension on it by pulling on it, and when you let go, it snaps back to its original shape, and it relieves all of that pressure. So what we feel is the vibrations that happen because of that. So it is either volcanic activity, so magma flowing underneath us, or the movement of those rocks near a fault line. We are feeling all of those vibrations and waves that are sent out from that. If you have an earthquake that happens out in the ocean, those vibrations are not encompassed by rock matter. They're going through water. When you have vibrations through water, what happens? Have you guys ever tossed a pebble in the water? It has the ripple effect. All those rings move out from where the pebble lands. The same thing happens when you have an earthquake in the water. It's going to cause that disturbance, and it's going to have that ripple effect, but on a more massive scale. So it's going to send those waves out from where the earthquake happened, and they're going to be giant, and they're going to build as they go, and that's going to cause a tsunami when it reaches land. Do you guys know what a tsunami is? Okay, really big waves that hit the shore, really strong, wash away stuff, knock things down. Very, very bad. If you're on one of the coasts of pretty much any country or island, you're going to run the risk of a tsunami. And most of them have a tsunami warning system, kind of like our tornado warning system. They sound the alarm if there's a tsunami expected. People move to high ground or move inland. So instead of going to their basements, they get in their cars and drive somewhere safe. All right, so we're going to go over each of the fault types a little bit more here. We talked about them briefly before. But remember that a fault is an area where there is some type of break or displacement of the rocks. A fracture is a break. So the rocks have broken apart or they've shifted somehow so they don't match up the way they did originally. There's movement possible in that area. So if you have a strike-slip fault, this is the transverse fault that moves side to side. So this is the one where you rub your hands together and they move opposite directions. This is going to be a shearing force. The shearing force just means when you rub past. Shearing is to break off. So if you have two pieces of rock moving past each other, they can break pieces of each other off. So this is going to be our transform boundary. You are going to need to know the type of force at each one of the fault lines. And you're going to need to be able to associate the fault types with a boundary type. There are test questions about this. So a shearing force is a strike-slip fault at a transform boundary, and it moves side to side. You will see images like this on homework assignments, on test questions. So hopefully that will jog your memory about this when you see it. Okay? The next one is called a normal fault. The top rocks are going to move down, so they're going to slide off of the bottom rocks. It is a tension force, and this is going to be a divergent boundary. So tension is when they're going to kind of pull away from each other, like that rubber band. So you pull the ends of the rubber band opposite directions, pull it away from each other, that causes tension. So what happens here is this section on the right is above the section on the left. There's no overhang happening here. It's just sliding straight down. So there's no overhang on anything when you look at a normal fault. It just slips on down and it causes that tension when it moves away. So tension forces are normal faults at a divergent boundary. You need to pay close attention when you're looking at images of these fault lines, because the next one is going to be a reverse fault, and it goes the opposite direction. So this is that same set of rocks, except the one on top is moving up. And you see how this makes an overhang right here over the top? So it's almost like the edge of a cliff hanging over the rocks on the left. So the normal fault, it just slips down. There's no overhang hanging over it. It's all open above these. The reverse fault, it moves up, and you have this cliff hanging over it here. So this one is compression force. This is when they're pushing towards each other, which means they are at a convergent boundary. They are converging or pushing together. And it's going to force one to move up over the top of the other one. Everybody see the difference between them? Normal, slides down, it's open above both sets of rocks, nothing hanging over. Reverse, this one slides up and you have this overhang right here. Okay? Again, you will need to know the type of force that happens for each fault type at each boundary. So reverse, compression, convergent. So this is a picture of your Strikeslip fault. This is a farm out in the California area, and they've already plowed the fields when the earthquake happened, so you can see how much it shifted. You've got a couple of inches here that it shifted over. So you no longer have straight lines in the fields here because that earthquake happened and it moved everything. Okay, we are going to do a quick couple of videos on some earthquakes so you can see them happening and see some damage. Go ahead and pause me right now and watch both of these videos. It's only a couple minutes each, and they'll give you some information about earthquakes in general and some good footage of some earthquakes. Okay, so what do we label when we're talking about earthquakes? We're going to label two major things, the focus and the epicenter. So the focus, both of these are vocabulary words, so hopefully you've heard of them if you've done your vocab. But the focus is going to be deep within the earth, in the body of the earth. So it's down in the internal layers. This is where the rocks are actually moving and rubbing against each other, crashing into each other, pulling away from each other. You have that actual movement of the rock. That movement causes the vibrations or the waves that are going to spread out from that focal point. So the focus is that point that starts the earthquake from the rock movement. All of the waves travel out in all directions from that point. The epicenter, on the other hand, is on the surface, and it's going to be where we see the most damage occurring. It's usually directly above the focus, and it's not necessarily going to be in a city. It may be out in the middle of nowhere, so the damage we would see would be cracks or crevices developing, or maybe a sinkhole happens, something like that. But it is usually directly above the focus, and it's where we see the damage on the surface. So we have two different types of scales that we're going to talk about. The one that most people are familiar with is the Richter scale. That's the one that was made for Southern California. It was created years ago. We started using it other places to make it a little bit easier to compare how strong earthquakes were. Americans in general are pretty much the only ones who still use this. It goes from 0 to 10, so it caps out at a strength of 10. You're not going to get an earthquake that's above a 10 on the Richter scale. We go 10 times increase in strength on this scale, and then a 3 is barely noticeable. A 5.5 is strong enough to damage buildings and roads. Higher than that, you're going to start having death rates. You're going to have buildings falling over, all kinds of bad things happening. The scale that scientists use now, we've switched over to the moment magnitude scale. It's again still 10 times in strength for each step. You still have the same general idea of a 3 is barely noticed, 5.5 starts causing damage. The difference here is with the moment magnitude scale, there's no maximum. It doesn't cap out. So you can get numbers that are 12, 15, 20 on the moment magnitude scale, whereas on the Richter scale it would stop at 10. All right, that is it for the notes for today. Once you are done with that, you're going to go back to your lesson page here. You should have already done the bell work. We just did the notes. So now you're going to do your tectonic plates map. You're going to add to that, and then you're going to do the earthquakes homework and turn in your fault lines map, which is your tectonic plate map with the fault lines added. So the homework assignment is one of the not a quizzes. You can take that as many times as you need to. Just click here, answer the questions, turn it in, and then repeat if you're not happy with your score. If you missed some questions, jot down what you missed so you know what to study. So let's take a look at your fault lines map assignment. If you scroll down, you'll see the finished map down here again. It's the same one that you had before. So let's take a look at the fault lines map assignment. This add the fault lines link is the same link that was on the lesson page. So if you've not already done it, add your fault lines to your map. This is the plate tectonics map that you drew. Make a copy of the fault lines map Google Doc and answer the questions below. So you're going to click here to make a copy of it, and then you have these questions to answer. Again, this is a link to where to find instructions for adding fault lines to your map. Then you're going to answer these questions for number 2, and then insert a picture of your finished map down here below this and submit this assignment. So the instructions for how to fill in the fault lines on your map are at this link. You're going to add all your fault lines around your globe. Use a different style of line for each type of boundary. So whether it's convergent, divergent, or transform, you're going to make a key on your map, label the major faults, and then research the New Madrid fault, add it to your map, and answer these questions below. These questions are some of the same questions that are on your homework assignment. You're just going to transfer it over from here to there. So there are a couple of extra questions in addition to these on there, but not many. So where do you find the fault lines? Scroll down to the next page and you have a picture of them. So all of these lines on here are going to be fault lines. There's a key down here. You can zoom in and out on this. If you adjust your zoom, you can go up to 200%. Zoom in and out, so you have red is divergent, yellow is transform, black is a convergent, and then the gray area is a subduction zone. So you're going to label these 3 types of faults. You're going to draw these in on your map using a different type of line for each fault. If you've got colored pencils, you can do them in different colors. If you've got a permanent marker or something that will go over what you colored in with your plates, you can use that, but you need to get these on here. I would also recommend putting the arrows to show what direction the plate is moving to help you figure out the boundary type. So get these put on there on your map that you drew, and then you're going to take a picture of the map that you drew, and you are going to insert that picture into your homework assignment here for the fault lines map before you submit it. Once you've done that, and you've done your questions in the other homework assignment, you are done for the day, and any time that you have left you can use for reviewing any missing work that you need to get done and turned in, doing the vocabulary, or reviewing material that we've learned so far and studying it, and then you are good to go. We will see you next time.